Hi everybody, my name is Alix Goguey. I'm a PhD student at INRIA in Lille, France, and currently writing my thesis. And I'm going to present you studies that we design and run with Mathieu Nancel, Géry, Casiez, and Daniel Vogel about the differences and performance between fingers and chords for common multi-touch tasks. So our work focuses on multi-touch interaction, which are interpretation of raw information provided by a touchscreen sensor. And among those informations, we mainly use the location of one or several contacts on a touchscreen, and also the number of fingers contacting the screen, which allows us to recognize gesture such as pinch to zoom. But given all the body capabilities and human abilities, the current input space of a touchscreen is quite small. And therefore, researchers seek to augment it, and as a result, it has become much richer. For example, we have now access to pressure, with the new generation of iPhones. Orientation, for instance, using the Kixo technologies. And we are still trying to find new ways to augment this input space. And the information I'm interested in is finger identification, which is knowing which finger is contacting the screen. The technology is not yet mature, but works have been done to explore what kind of interaction we can do with this information. So, for example, a simple example would be mapping different commands to different fingers. So, for instance, drawing a rectangle using the index finger and drawing an ellipse with the little finger. But wait, since we are using different fingers or chords, can we use them as if they were all equivalent? What do we know about the performance for each chord and each finger individually? Do they yield the same performance? Surely not. But how then are they ranked? And for the ranking, is it the same depending on the different type of gestures? And also, in the meantime, is it okay to ask users to point or drag using, for example, the little finger? So we looked at previous studies comparing performance with the touch modality, and some studies did not control which finger were used. Some reported it, and some controlled it. And among those which controlled it, most were pointing using only one finger. In those works, half tested only one finger, a third tested between 2 and 4 fingers, and only 3 works tested all the finger of the dominant hand. And as for the chords, only 2 works look at transformation with a single 2-finger chords. So to our knowledge, no study looked at all 10 fingers for pointing or dragging. And for the 2-finger chords, they still need to be evaluated. And that's where we place our work. So since we don't have the big picture of concerning the difference of performance between fingers and chords, our work aimed to fill up some blanks. So we tested all the fingers of all the 10 fingers, and in this talk I will use the term dominant and non-dominant to normalize left and right-handed participants. We also tested pairs of fingers, which I will refer to as chords. So we tested chords only in the dominant hand, and those chords were divided into 2 groups: pinches with thumb and index, thumb and middle, thumb and ring, and thumb and little, and adjacent chords, which are index and middle, middle and ring and little. Okay. So we compared all the fingers and the 7 2-finger chords through pointing tasks, dragging tasks, rotating tasks, only for the chords this time, and scaling task, again, only for the chord. And the objective is simple: it's to reveal potential differences and discuss the mapping between commands and chords or finger. Our experiments were all run on a Nexus 10 tablet. And the first question we wanted to answer is, what sizes should we use for the targets and avoiding the fat finger problem? So in a first experiment, we displayed circular targets at random locations using 6 different sizes. And we asked participants to tap targets without giving them any instruction for speed nor accuracy. And no error feedback was displayed. So for the experiment design, we had 2 primary independent variables, contacts, which cover both chords and fingers, and tolerances. And after analyzing the results, we found that for most fingers, a target size above 17.5 millimeters comfortably allows an error rate below 5%, which is in the range of target sizes recommended by the literature. And for chords, the minimum size needs to be at least 36 millimeter and often 40 millimeter. But recall that in our study, we did not instruct the participants to be accurate, and we did not provide them feedback. So in the next experiment, to assess the accuracy, we tested values that are smaller, equal, and greater than what we found. And the second study is therefore 4 fit-like experiments, which each tested a single task. So we had a pointing task, where participants were required to tap a target, a circular target, circular start area, and then tap a circular target area as fast as possible, and keeping an error rate around 4%. And unlike in the first experiment, they were provided feedback whenever there was an error. So, a classic, the tolerance was the diameter of the target, the amplitude was the distance between the centers of the start area and the target area. Here is the experimental design. So contacts, tolerances, and amplitudes were our independent variables. Then second task was a dragging task, where participants were asked to drag a circular token, into a target area. Again, as fast as possible, and keeping an error rate around 4%. The tolerance was the diameter of the target minus the diameter of the token, and the amplitude was the distance between the centers of the token at its initial location and the target area. The dragging experiment had the same experimental design as the pointing one. Then we had a rotating task where participants were asked to rotate a key inside a target area, again as fast as possible and keeping an error rate around 4%. And only chords this time were tested, since you need at least 2 points to rotate. The tolerance was the target aperture minus the key aperture, and the amplitude was the aperture between the bisectors of the key and the target area. Again, the experimental design was the same, except that here only 7 chords were tested. And finally, we have the scaling task, where participants were asked to scale ring-shaped circular object into a ring target area as fast as possible and keeping an error rate around 4%. And this time only pinch chords were tested, so all the chords involving the thumb. The tolerance was the width of the torus target area, and the amplitude was twice the distance between the token edge and the torus target area. Here is the experimental design, which was the same, except that only 4 chords were tested. And at the end of each experiment, we asked participants to fill up a questionnaire evaluating their preferences between fingers and chords, And for each contact, we asked them to mark their perceived ease of use, speed, accuracy, and fatigue. For our analysis, we used the Shannon formulation of the fit-slow model and throughput as an overall indicator of performance. So in the paper, we report the detailed results, such as the values of the parameters, the throughput, and also the index of performance for completeness. But here I'll focus on discussing the mapping between commands and contacts. And to do so, we based ourselves on throughput and mean preferences, since all the categories followed the same trend. So for each contact, we computed a score based on the post-hoc differences we found. So a contact had an initial score of 0, and then for every significant result, we add 1 when the contact was better, and subtract 1 when it was worse. And based on the cluster it produces, we formed 3 groups: contact to prefer, contacts to avoid, and neutral ones. Okay. So here are the cluster for the pointing. So we can see that we are quite good with all the finger of the dominant hands, and only the ring and little finger of the non-dominant hand should be avoided. And as for the chords, we should avoid the pinches using the ring and the little fingers, and the chord ring and little. So following the cluster, and for a copy-paste example, for example, you may choose the dominant index to copy and the dominant middle finger to paste. Right. For the dragging experiment, the cluster looked the same, except that the dominant little finger now joined the group of contacts to avoid, which is mainly due to the fact that we don't like using this finger for dragging. And so if we go back to our first example, you may choose this time the non-dominant index to draw rectangles, and for example the dominant index to draw ellipses, but not the non-dominant, the dominant little finger. The clusters for rotation are similar to both pointing and dragging, meaning that we are quite good actually and not annoyed to rotate with non-pinch chords. And finally, the cluster for the scaling experiments follow nicely the order of the fingers. But we can discuss finer mappings. So here we grouped preferences and performance with a same score, but what about splitting them? So for instance, we could discuss the use of less efficient fingers or chords for general commands, which does not need to be triggered at a particular location, or use less preferred fingers or chords for critical command, and try avoiding using those chords and finger, triggering those commands by accident. And then we can place commands like save, which is general and not critical, erase, which is critical and localized, and close, which is both critical and general. Further work still needs to be done to evaluate more chords. So, for example, all the remaining chords of the dominant hand, obviously all the chords of the non-dominant hand, and even evaluating more chords with more fingers, or evaluating the differences and performances for other gestures like swiping. So, as a summary, so in order to better understand how to design multi-touch interaction using finger identification, so we presented fits-like studies comparing all 10 fingers, 7 two-finger chords, through common multi-touch tasks. And based on the results we found, we proposed guidelines to better map command to fingers or chords. Thank you for your attention, and if you have any question, I'll be happy to answer it. Thank you.
Liked your talk very much. Oh, by the way, I'm Marilyn Tremaine. I just want to translate this to another field. Obviously, when people play music and they're trained to play music, they're trained to use different fingers for different chords. And I wonder if you looked at any musicians and what's happening with how they use your fingers, and if that has an impact on your work or there's similarities.
So we unfortunately didn't look at musicians, but actually there was a professional pianist that at some point wanted to use finger identification for evaluating how chords are performed and try to come up with a new way of teaching the right chords for younger musicians.
Just personally, I'm quite surprised by the number of people who actually use thumb primarily on touch screens rather than finger, especially in one-handed situation. I wonder if your study shed any light on that.
So no, because in our studies we imposed which finger to use, and therefore there was a predefined number of trials with each finger, and so there was no part of letting the user choose which finger to use. So fortunately in those studies we cannot assess or look at that problem.